Everybody, welcome back to my channel. Today we'll be starting with module 2 of chemistry. So these are the following topics, main important topics of this chapter. So we'll be starting with the first topic, electrochemical theory of corrosion. I'll try my best to keep all of these topics under 10 minutes, so it's very easy for faster revision. Answer all concept based. You can refer to the notes once after understanding the concepts. It's going to make it easier, but anyway, I'm going to cover how much ever possible in these videos as well. So let me start with the first topic. This I'll come back to it later. So let's start. First of all, the chapter's name is what? Corrosion, metals, finishing, all of that. Do we know what corrosion actually is? We must have seen rusting or that. Yes, that is corrosion, but definition wise, if I have to say, in corrosion, what is exactly is happening is the destruction of a metal due to electrochemical attack of atmospheric constituents. The destruction of a metal or the conversion of a metal to its metal oxide or destruction of its metal because of attack of atmospheric constituents, because of electrochemical attack of atmospheric constituents. The metal becomes metal oxide, the metal becomes destroyed. Corrosion of a metal is an electrochemical phenomenon. Do we know what electrochemical phenomenon is? In the previous chapter, we have seen electrochemical reaction. What did we see? Basically, from chemical reaction, we are producing electricity. Correct? So, electrochemical reaction, galvanic cell phenomena also we can say. So, here anode will be there, cathode will be there. Anode will undergo oxidation, loss of electron. Cathode will undergo reduction, gain of electron. However, in corrosion, cathode will not play a role. It's going to remain unaffected. Remember, it's a very important point. In the future, when we are seeing corrosion control techniques and other different topics, it's very important that you keep in your mind that cathode will not play a role in corrosion. It's going to remain unaffected. Anode is going to undergo the reaction. Anode is going to undergo corrosion. That also have to remember. Okay. So, when a reactive metal like iron is exposed, let's take an example. This is iron. It is exposed to atmospheric, like say oxygen, acidic medium, neutral medium, whatever it is exposed to the atmospheric constituents, it's going to form small anodic and cathodic regions. It's going to form across the material. I'm just think of it as a zoomed in version. This is going to act as the anode, this is going to act as the cathode. In anode, obviously, what is going to take place? Oxidation is going to take place. Means loss of electron. So iron is going to become Fe 2 plus 2 electrons. Now what reaction is going to take? Now this 2 electrons, whatever is there, that's going to go to cathode. But cathode it's a metal. It's not in metal ions form. It's not going to accept the electron. It's not going to accept the electron. So what happens in the atmosphere? Whatever constituent is there, this is going to go to that. The electron is going to react with oxygen or water or hydrogen. That reaction I will tell you. Those reactions I will tell you in a while. But you understood, right? The electron is not going to go. It's trying to go to cathode, but the cathode is not going to get reduced because it's in metal. It's not a metal ion form. So that's going to react with the atmospheric constituents, right? So suppose it's going to react with H plus. Say the electron 2H plus 2 electron is going to become what? H2. Correct? Suppose it's going to react, the electron is going to react with water, you say H2O plus electron is going to react to form OH minus ions. Okay. Just example balancing you guys can do. OH minus ions. So finally the metal oxide, whatever OH minus ion there, finally metal oxide reacts to the OH minus ions. Now this OH minus ion, what is going to form? Is going to react with the metal, and that is going to form MOH. That MOH is what? Metal hydroxide. See, I'll just tell you. Anode, it's going to get oxidized, so basically loss of electrons. So Fe is going to become Fe plus 2 electrons. The electrons are going to react with the atmospheric constituents. After, suppose it's going to react with water, it's going to form metal hydroxide. The metal hydroxide will in turn react with the metal. The hydroxide is going to react with the metal to form metal hydroxide. How was the metal hydroxide formed? The electron is going to react with water. Hydroxide is formed. Hydroxide reacts with metal, forms metal hydroxide. The metal hydroxide, after further reaction, is going to convert into metal oxide, and hence the metal is corroded. Corrosion has taken place. Okay, don't confuse too much. Now I'll explain you. Taking iron as an example only, I'll explain you. The metal is here is what? Iron. The medium or the electrolyte which is taking place is the air. Atmospheric constituents I'll take. So in anode, what is taking place? Anodic reaction. Fe is getting into Fe2 plus 2 electrons. This is the oxidation. Iron is dissolving into its metal ions form. Electron is going from anode to cathode. Electron is going to atmospheric constituents because cathode is not going to get reduced. So in cathode, I will write like this. There is two cases. Okay, one is liberation of hydrogen and one is absorption of oxygen. And here also there is two cases. One is in acidic medium with H plus and one is in neutral medium with H2O. This electron, what is going to happen to it, that we are telling now. Okay, so H plus 2 electron is going to become H2. So 2H plus I can take here, correct? Next, the 2 electrons can react with water also. This is different cases, okay, different cases. H2 can react with the 2 electrons to form. Do not involve oxygen here. It's giving liberation of oxygen. You have to liberate oxygen itself. H2 plus OH minus. So 2 electrons. So 2 OH minus. So 2 plus 2 4. So 2 H2O. You understand? H2O plus, you have to remember the reactions very importantly. Remember that's what, when they are saying liberation of H2, don't try to involve oxygen here. Liberation of H2 means liberation of H2 only. React that with what is the medium here? Neutral medium, water. This one, it will form OH minus and H2, so it's going to get that is one of the products. Now absorption of oxygen. In acidic medium, H plus O2. H plus is there means H2 will get liberated. Sorry, electrons also, my bad. That is only the main thing. H2O. 2, so 2. 2H plus. So, no, this is going to become 2 again. So, 4. So, 4H plus. So, 4 electrons. Okay. Balancing you can have to learn slowly. So, 4H plus O plus 4 electrons going to become 2H2. Then absorption of oxygen in near this medium. So, H2O plus O2 plus electrons is going to give you what? When water is not there on left side, bring water as well. When water is there on left side, don't bring water here. You have to bring OH minus. Okay. Again, have to balance. 2 is there, but want to make this 4. So 4. So 4. Did you understand how did you write the equations? This is important. You have to understand how did you write the equations. Now, what you have to understand is that in anodic species, in anode reaction, Fe2 plus was the active species. In this cathodic reaction, what just we did here, OH minus is the active species. So this Fe2 plus and OH minus will react to form FeOH twice. You have to remember this consciously. Fe2 plus and OH minus, balance it, OH twice. So 2OH. Fe2 plus 2OH minus will form FeOH twice. This FeOH twice will further react with water and oxygen to form Fe3O4 dot XH2O. FeOH twice will react with water and oxygen to form Fe2O3. Oh my god, it's a big blunder. Fe2O3 dot XH2O. This is a yellow, rustish yellow. So Fe2O3 dot XH2O is a hydrate ferric oxide. Now in limited oxygen, the same FeOH twice in limited oxygen will form Fe3O4 H2O. This is a black rust. Okay, alright. That reaction is understood, right? Anodic, cathodic, or do you want me to revise it once again? Okay, quickly, I just do it once if you want. In anodic reaction, what did we see? Fe is going to become Fe2 plus 2 electrons. Okay, that's anode. This 2 electrons should go to cathode, but it's going to go to the atmospheric constituents because cathode is not going to get reduced. So cathodic reaction, what right now? Cathodic reaction, there is one liberation of H2 and one is absorption of oxygen, and that is in case acidic medium and neutral medium. In acidic medium, we have to liberate H2 by writing with the H plus plus 2 electrons is going to form H2. So let's balance it. 2H plus 2 electrons, H2 is getting liberated. Similarly, in water medium, so H2O plus 2 electrons is here. H2 is there, so you have to form H2 is going to get liberated. Apart from that, you have to liberate OH minus as well. So 2, so I'll make it 2 here. So 2 OH minus, so correct. 2 H2O plus 2 electrons gives H2 plus 2 OH minus. In absorption of oxygen in acidic medium, you have to H plus O2 plus those electrons, you have to get water here. So 2 is there, so this is going to become 2H plus, so 2 electrons. No, this has to become 2, so this is going to become 4, so this is going to become 4. So 4H plus O2 plus 4 electrons is going to become 2H2O. Next, absorption of oxygen in neutral medium, H2 plus O2 plus electron, it's going to give you now OH minus ions, because if left H2 is there, right, you should not bring. You have to consciously remember that. So here 2, so 2 plus, so I'm going to make this 4 now. So 4 is there, so here 2, so 4 electrons. 4H2O, sorry, 2H2O, O2, 4 electrons gives 4 OH minus ions. This you understood. So here active species in anodic was Fe2 plus. In cathodic it is OH minus. So Fe2 plus OH minus will form FeOH twice. You have to remember the products. So FeOH twice will further react with XH2O and oxygen to form Fe2O3 dot XH2O. This is a hydrate ferric oxide, and in limited oxygen it's the same. FeOH twice will form Fe3O4 H2O, which is black rust. And what did I say? Electrochemical phenomena of rust. This was. But in real, what's happening is anode is only going to undergo corrosion, cathode is going to remain unaffected. That is only you have to remember one point. This was only the electrochemical phenomenon of rust. Fe2O3.XH2O is the actual rust in normal oxygen, all of that. This is black rust in limited oxygen. So I hope I have explained it well. So see you in the next one. Thank you for watching. Bye bye.